Okay, and we'll keep that Mentimeter running in the background. So please continue to submit your answers just while we introduce this webinar and we'll get started. So thank you all for joining us today for our final webinar in the series of our triple planetary impact webinars. Today we're focusing on fibre fragmentation and climate change. And we are joined by a range of guest speakers today that I'm going to introduce to you very shortly. Just some further information. Mics and cameras are off today. And this webinar is being recorded. We will not have time for Q&A, but we still have enabled the Q&A function, and we can compile these questions and answer by email if we don't get time in the webinar today. So I'll just quickly run through the agenda. I'm going to introduce our speakers and provide some context for this webinar before handing over to Kelly to provide some further information on our position on fibre fragmentation and the triple planetary impact. One of our guest speakers, Lucy from WWF, will be introducing the impact that the fashion industry has on climate change. And this will be followed by evidence presented by our researcher, Elliot, as to the connections between fibre fragmentation and climate change. We'll then be running over some strategic alignment and integration. So what we mean by this is how you can incorporate fibre fragmentation action into your climate strategy. We now have a wealth of tools and resources available for you to do this, and we'll be sharing further information about that before launching into a fireside chat between Phil Patterson and Sophie Mather, who I shall introduce very shortly. Then we will provide a final call to action and close today's webinar. So just from TMC, the presenters today, we're joined by our CEO, Kelly, researcher, Elliot, and I am Anna Bateman, Senior Stakeholder Ambassador at TMC. Now, to introduce our guest speakers, so Lucy Polhill is the Business and EPR Coordinator for WWF International's No Plastics in Nature initiative. She holds an MSc in Environmental Science and has published research on the susceptibility of microplastic ingestion in freshwater species. Lucy's work focuses on emerging themes such as the circular economy, extended producer responsibility, corporate engagement, and tackling microfiber pollution in the fashion industry. With a career dedicated to freshwater and marine conservation, she is deeply committed to addressing plastic pollution on a global scale. Thank you for joining us, Lucy. We're also joined today by Phil Patterson, Managing Director of Colour Connections Textile Consultancy. Colour Connections provides advice, information and training on dyeing, printing, finishing, colour management, restricted substances management, and sustainability to all parts of the textile supply chain, from industry right through to retail. Phil has also managed projects on eco-efficiency of dye houses for both the UK government and the World Bank, and is a passionate advocate for reducing the water, energy, and chemical use in wet processing. Phil serves on the Apparel Impact Institute's Climate Solution Portfolio Advisory Council, evaluating CO2 emission reducing solutions and innovations for grant funding and developing energy and emissions benchmarks for the industry. Thank you for joining us, Phil. And last but not least, you may recognise this very friendly face. Sophie Mather is founder of the Microfiber Consortium and joins us today as a guest speaker. Her journey on microfibers began in 2016 with a curious observation: a bold patch on a fleece jacket and trade show carpet shedding fibres in excess. As a constant questioner of why, these small moments led her to investigate the environmental impact of microfibres on the air, water, and ecosystems. Sophie specialises in material innovation and has spent the last 8 years working on this topic as close to the root cause as possible, supporting the industry in understanding, engaging, and implementing change. Sophie views materials as a lever for new approaches, and in today's conversation with Phil Patterson, we'll be delving deeper into the magic of materials, and in particular as to how they can support change in regard to not just fibre fragmentation, but climate too. Since stepping out of TMC very recently, Sophie supports the industry as a material futurist with Biovation at the brand, supplier, and innovator level. She prides herself on working on emerging areas that look to solve the complex environmental issues faced by the clothing industry through material interventions. So that's an introduction to our guest speakers. I'm just going to provide a quick disclaimer here that fibre fragmentation is really the true focus and remit of the Microfibre Consortium. And we do not we wish to encourage proportionate action to be taken in this area, alongside other efforts to reduce the negative impact of the fashion and textile industry. So today's conversation is really important about how these actions can support each other. And I just want to give a quick roundup, some context for this work, which I think is really important to further understand this conversation today about fibre fragmentation and climate change, because for many, I think it may be a first time in connecting these two issues. And so it's really important that we provide further information on how we got here today. And TMC was founded back in 2018 to address what was then a largely unknown issue, with a primary focus on plastics and marine debris and domestic laundry. That was where kind of the microfibre issue really began. Our founder, Sophie Mather, with her background in material innovation, sought to address this issue at the root cause, which we see as the fabric itself. Research and understanding since then has come such a long way, and there are new papers coming out on fibre fragmentation almost every week. We know that it is not an isolated issue, and there is growing evidence that has established that fibre fragmentation is interconnected to biodiversity loss, environmental pollution, and climate change. If you have been following our full webinar series, you will know that climate change is the third impact area of the triple planetary crisis that we are tackling, but you can go back and catch up on our webinars on biodiversity loss and environmental pollution, which provide further evidence as to how fibre fragmentation is truly interconnected to these impact areas. So I just want to say that if you're listening today and you're setting your strategies, which we'll go back to that Mentimeter shortly and see who's here and is currently developing their strategy. We want to just ensure that you consider microfibre pollution as part of your climate strategy, and we're excited to have this opportunity to present evidence as to why that is important today. We do feel at the Microfibre Consortium that without addressing this, a crucial piece of the puzzle would be missing. However, if you're listening today and this topic is new to you, or you're currently forming your climate strategy, then it's just great to have you here on this journey with us. And please stay tuned for further opportunities that are available to further your knowledge in this area. So it's a complex topic, but we know that when the shift happens and fibre fragmentation is no longer seen as a siloed issue, we will be able to accelerate from the emerge and activate stages to true implementation and scaling of this action to support positive change throughout the industry. I'm now going to hand over to Kelly. I'm just going to bring up those Mentimeter results. So bear with me just one moment.
Thanks, Anna. Just whilst you're bringing up those Mentimeter results, I'd just like to say thank you to everyone for joining today. It's one of the three webinar series that I've been most looking forward to, and really hearing how this topic has moved throughout the years. And Anna, are they the results? Hold on, I need to make my screen.
Yes, we actually still have, someone's just voted. If you didn't catch the link, as there's been a lot of people joining us, please do click this link and vote. But it looks like so far the
we've
responses,
had one, yeah.
So does your organisational climate strategy feature fibre fragmentation action? The vast majority are responding, not yet, we are still developing this, which I think that's to be expected. So thank you for taking part there. Yeah, still more coming in.
Yes,
one yes.
I think the general results are what we might expect. We are all on a journey with this, and part of the reason for this webinar series is to join that together. Can you switch to the next slide, please, Anna? We know many of you on the webinar today have joined us in our previous environmental pollution and biodiversity webinars. But I think it's important for those of you who haven't joined us on those previous webinars to put this into context and talk about the reasons why we're doing this, and particularly TMC's position. I'd just like to highlight for those people that we put out a simple 2-page document earlier on in the year, which you can access through the QR code that's on the screen. And the intent of this positioning statement was really to introduce the idea of moving away from the topic of fibre fragmentation being a niche and silos one to one that sits across and is supported by the larger sustainability agendas of environmental pollution, biodiversity loss, and climate strategies. And within the position statement, we really explain how that is ratified from the scientific evidence that is both existing and is emerging and coming through in the future, with clear action points that you can take both as an individual, as an organisation, to address it. And if we can put that in a bit more of a visual perspective and take that report to the next level, many of you will be recognise the wheel that is on the left-hand side together, which TMC has been using for a while to demonstrate the process steps of design and development of a material, each of which determines how a material sheds fibre fragments from it and that are subsequently released into the environment. And that release, we know through research that's been undertaken, is through one of three pathways: air, water, and land. And we are now connecting those fibre fragments that are lost from material, released through one of those pathways into the environment, with impact and environmental impact. And that's the introduction of the wheel on the right-hand side, is the topic cuts across and connects to environmental pollution, biodiversity loss, and climate change. And as Anna mentioned before, the three triple planetary crises. The scientific evidence to support this work and these findings, and the link of fibre fragmentation to these environmental impacts, is scaling, and we'll continue to see more of that that demonstrates these environmental impacts. And that is from fibre types, whether they are natural, man-made cellulose, or synthetic. And linking both of these wheels is the change that can be delivered through a material strategy, which in turn feeds into changes through design and development, which can reduce the loss of fibre fragments from those materials and subsequently reduces the impact that they have on the environment. And it's fair to say that within these three impact areas, they are all at different stages, both in knowledge, scientific knowledge, but also in our knowledge and understanding. And that's why I describe it very much as a journey. And that has been demonstrated through the results of the Mentimeter earlier, where many of you have climate strategies, but don't yet know how fibre fragmentation can link into that. And hopefully this is the start of the conversation today of how together we can do that. So today, particularly, we are focusing on climate change, and I am really pleased and honoured to have Lucy Polhill from WWF, who is going to talk to you in framing the problem within the work that WWF are doing on the area. So I'm going to hand over now to Lucy.
Thank you, Kelly. Can we go? Oh, perfect. Well, good morning, good afternoon, or good evening, depending on where you are in the world. But today I'm here and I'm really excited to share insights into the critical links between the fashion industry and climate change. And so as part of WWF's freshwater and plastic team, we've been working to address the significant environmental challenges posed by the apparel and textile sector. And the numbers are staggering. In 2021, the apparel industry was responsible for 1.8% of annual global emissions. Over half of these emissions come from material processing, and nearly a quarter are linked to raw material cultivation and extraction. Next slide, please. And so this gives you a quick overview of the full textile value chain. And so the highest impacts to nature and people are from tier 4, tier 2, and then as well as the last two use phases. And so tier 4 is the raw material extraction, and then tier 2 is material production. And so this is the production and finishing of materials that go directly into finished products. And then the last two phases are consumer use, the consumer care, including washing and drying, and then it's end of life. So whether or not it gets reused, recycled, landfilled, or incinerated. Thank you. So looking ahead, the challenges deepen. Plastic waste generated from synthetic textiles is expected to more than double in 2060. This was through a recent report put out by OECD. And meanwhile, our consumption patterns have escalated. People are buying twice as many clothes as before, and more than half of the fast fashion produced is disposed of in under a year. And so you can see on this graph here how it's doubled over time. Sorry, next slide. And so this growth contributes to the 92 million tons of waste annually, much of which ends up being incinerated, dumped in landfills, or polluting our natural environments through microfiber shedding. And 70% of textiles collected for reuse are exported to countries with no collection infrastructure. And globally, less than 1% of garments are closed loop recycled. And this brings us into why there is such an urgent call to action on microfiber pollution. So microfibers represent a pervasive and persistent pollutant, posing a global threat to both people and nature. And what makes this issue so particularly urgent is that shedding occurs throughout the entire textile value chain, affecting species across every ecosystem. Yet this isn't just a crisis, but also an opportunity. The apparel and textile industry has a pressing need to act, especially on microfiber pollution, and WWF is ready to lead and support efforts to drive meaningful change. I've seen firsthand from working in circularity for plastics that these principles can be applied to textiles. And there's tremendous potential to reduce the impacts and transform the industry. And so with that, I'll hand over to Elliot to explain more about the links between climate change and microfibers.
Thank you,
Thanks,
Lucy.
Lucy. Yeah, so I'm Elliot. I'm a researcher at the Microfiber Consortium. So we've heard a bit about how the textile industry overall contributes to climate change, things like material extraction and production. What I'll talk about for a little bit now is just about how fiber fragments or microfibers specifically can be linked to climate change. So as Lucy said, fiber fragments are released by textiles throughout every life cycle stage, so manufacturing, consumer use, and end of use stages. And we know that these particles are accumulating in the environment and have potential negative effects, which is something that we've discussed in previous webinars. Until now, well, until recently, microfiber pollution and climate change were really being thought of as separate issues, but recent research is starting to find that the two are actually interconnected through several pathways. So there's 4 points that I'll mention today: ocean, soil, air, and direct emissions from microplastics. So before I go into detail, I will state that most of the research at the moment, or all of the research at the moment, has been focused on microplastic fibers. So fiber fragments released from synthetic textiles are microplastics, fragments from natural materials like cotton are not, and it has not really been uncovered yet if or how natural fiber fragments are connected to climate change. That isn't to say that there's no connection, it just isn't the focus of the research at the moment. But we know that most of the microplastics in the environment are fibers from synthetic textiles. So to start with, the presence of microplastics in the ocean can disrupt carbon storage potential by affecting organisms which play key roles in the carbon storage of the ocean. So things like plankton can be affected through toxicity due to the physical presence of the particles or the leaching of chemicals from manufacturing. They can also impact sea ice in polar regions. So microplastics can enhance the melting of sea ice with potential effects on global sea level. These interferences in the ocean can contribute to the accumulation of CO2 in the atmosphere, which, as we know, intensifies global warming. Microplastics in soils can be polluted either from the air or from fertilizer sludge from wastewater treatment plants. Soil has a major role in the production and consumption of 3 key greenhouse gases: carbon dioxide, methane, and nitrous oxide. And the release of these gases is shaped by microorganisms that are in the soil. So most of the research in the field of microfibers and microplastics has been focused on their effect in the ocean, but it is now known that microplastics are accumulating in soil, potentially at higher concentrations than the ocean, and they can have toxicity towards organisms, microorganisms found in the soil. So greenhouse gas emissions from soils can be accelerated by the presence of microplastics due to their effect on soil ecosystems. So there is evidence that soil contaminated with microplastics releases greater levels of greenhouse gases. And microplastics in the air have the potential to impact the formation of clouds, which can then have knock-on effects on weather and climate. And the final point is that microplastics themselves will generate greenhouse gases directly into the atmosphere. As plastic degrades, it can release methane and ethylene. The release of these greenhouse gases from microplastics may be larger, maybe more than from larger pieces of plastic due to the greater surface area of microplastics, meaning that they are easier to degrade. So these processes, they don't just exist in isolation, they create a feedback loop. So climate change will cause more frequent and severe storms or weather events, which can then impact the transport of microfibers through the environment. For example, increased storm overflow in wastewater treatment plants, or runoff from microfibers and microplastics in soil into the ocean, which can then in turn affect climate. So the relationship is really complex and multifaceted, and it involves both direct and indirect interactions. More research is really needed to understand the effect of microfibers, microplastics, and natural microfibers, the effect of these on climate. It's still a fairly new topic of research, but there is certainly enough evidence at this stage to suggest that microfiber pollution and climate should not be considered separate issues in the future. So I think I'll pass back to Anna there, maybe, or Kelly.
Yeah, I think it's me. Thanks, Elliot. And I think it's really interesting to see how that research is now developing And as I mentioned earlier, the journey and the knowledge and understanding from a scientific perspective for those 3 planetary impact areas is very different. And climate is one of the younger of the areas in terms of fibre fragmentation, which is why at the moment there's a concentration of research being undertaken in the field of microplastics specifically that has not yet extended into the wider types of fibres that we see research for in environmental pollution and biodiversity loss. It's important really to put this into context of what we're trying to do at TMC and the reasons why we are talking about this subject. As we developed the roadmap back in 2021, we entered a phase of activation where we were raising the awareness of the subject and aligning the agenda together. As we move into 2024, we are now moving into the implementation stage, and this is really gearing up for scaling back at the end of 2028. And in order to do that, we need to move this topic from one that sits on its own to one that sits across those broader sustainability agendas that we have talked about, and we start to connect the dots. And that's not only for that is really to help the industry to streamline the work that it's doing, where things aren't done in isolation, and one sustainability agenda is not competing against the other. We really see fibre fragmentation and fibre fragments as something that is connecting the dots within them and can be used to support you with the development of your sustainability strategies in making improvements, particularly around materials. So as we look to revise the roadmap, I think it's fair to say our knowledge is at a completely different place today than it was back in 2021. The industry is certainly in a different place, and we have taken the decision that we're at the right time to revise that roadmap going forward. And a particular focus of ours is the integration of the topic within those wider sustainability agendas. How do we do that? Well, again, I keep mentioning a journey, and at the moment we're at the journey of starting to seed this idea. And I think something that Sophie may discuss later in the webinar is, when we started and she started her microfiber journey and started to discuss this within the industry, it was very much unknown, and how we could tackle that to mitigate the loss of microfibers. We have learned and taken steps along the way to develop our knowledge and fill gaps in knowledge and move towards actions that we can take to mitigate that loss. We're at the very beginning now, where we are seeding the idea to you. And then we need to move forward through providing the evidence and the support that we hopefully are providing within the previous 2 webinars and this one. And as we move away from this into 2025, it's then important that we're able to come together and strategize and collaborate on how we can move this forward. And the next stage of the journey, Anna will speak to you about towards the end of the webinar and what those next steps are. We see opportunities beyond that, where signatories can begin to share their material strategies, so we can develop better alignment, moving into scaling this, where we start to make clear connections between how reduction of shedding of materials from finished fabrics, but also within the manufacturing industry, can help to demonstrate impact within these environmental areas. Next slide, please, Anna. I mentioned that we don't see these as being siloed, and the tools and resources that TMC have already developed can help to support you within each of those strategies, whichever yours may be within the organisation. We have talked over the past 2 webinars and indeed in this one, how fibre fragmentation cuts across all 3. And we can support you within your agenda within all 3, but some tools and resources lend themselves to certain areas more than others. So, for example, within climate, you've seen from Lucy speaking earlier that half of emissions come from the manufacturing process. And the tools that we've developed, including guidance for the manufacturing industry on how they can reduce fibre fragmentation release into wastewater, can be used to support you and your climate strategy going forward. Next slide, please, Anna. So some of those tools and resources highlighted on the screen can also be downloaded if you scan the QR code. They are all available on our website. You just need to complete your details and you'll have access to that. And we hope that you will start to use those and distribute them throughout your organisation and supply chain for use. And with that, I am very pleased to introduce our 2 speakers who are going to have a fireside chat between them, and that is Phil Patterson and of the founder of TMC, Sophie Mather. And this is something that I'm really, really looking forward to. Sophie and Phil both started their journey of fibre fragmentation a long time ago, and it's going to be really interesting to see how that has developed and also how they see that developing in the future and how material strategies can be addressed in order to reduce carbon emissions and create that more concrete link between fibre fragmentation and climate change. So with that, I'll hand over to Sophie and Phil.
Thank you very much, Kelly. Yeah, when you say we've been doing it a long time, it feels like it's been a long time. But when you think about the clothing industry, it's actually quite a short amount of time that this topic has been around. So when we talk about it as an emerging topic, and then today talking about it as it cuts across climate as well, it's still a relatively short period of time. So I think we've got Phil here as well. I can't see him at the moment. Phil, are you there?
I'm here, Sophia.
Super. Okay. Wonderful. Okay. So yes, as Kelly said, Phil and I have been on this journey for a little while. And I know, Phil, you've supported the Microfibre Consortium in various different roles with different hats on, first as chair of our advisory board and our technical committee, and now more recently through the crossover work between TMC and ZDHC. So I'm super excited to join you around the fire today to kind of get a little bit deeper on this and how it kind of cuts across the 2 areas. So thank you for joining us.
Pleasure.
Can we maybe start, Phil, for those on the call today that aren't aware of the work that you've done? I know you were introduced at the beginning, but what's the kind of the key area that you're really working on here, that you're bringing forwards with regards to kind of climate and the textile industry?
Well, I'm working with the Apparel Impact Institute on their climate solutions portfolio at the moment, and that is looking at bringing solutions to the industry that can reduce energy consumption within a facility and or reduce emissions via either renewable energy or efficiency of on-site utilities, processes, anything really that can reduce that energy consumption and emissions. And that's sort of in an organised way, but I'm also working with various clients to evaluate lower impact processes, machinery and things like that.
Great. And I mean, today we talk about it under the umbrella of climate, but I mean, it hasn't always been that way. I know for myself, when I first started working on this, I suppose, it wasn't called climate. We talked about energy efficiency, we talked about waste, pollution, etc. When did your journey first start on this? Is it something that goes back a little way? I know for myself, perhaps early 2000s is when it was first kind of brought up in the work that I was doing.
Yeah, it probably in the early 2000s again for me when I was working at Marks and Spencer as dye printing and finishing manager, that we started to look at efficiency, wanting to look at water use, energy use, chemical use. So the three things are all linked together. I think at that stage we're probably more aware of pollution and water scarcity rather than climate issues. But of course, a great thing that happens is when you reduce your water use, you reduce your chemical use, and you use your energy use. So initially, it was around that efficiency work, really.
Yeah, I think, yeah, same for me. You know, working with the factories at the time, it was very difficult to kind of talk about climate. But when you start to talk about efficiencies, you pique the interest of people in a factory that are all about efficiencies. And I think that hasn't changed today. So when we are talking within the supply base, within the manufacturing, talking about efficiencies is key. So yeah, good to hear that you've kind of been on it a little while. So where did your kind of curiosity for this, where did it first start? Was there something in particular that piqued your interest in fibre fragmentation and this work here?
Well, it was a bit of a one of those where you kick yourself, because most of my grey hairs come from when I worked in industry, working in a cellulosic material dye house, and then working on process development for lyocell, and with lyocell particularly. You get masses of lint formed. You've got a biopolishing process there, and the machines are full of microfibers essentially, and it's a nightmare trying to deal with them. So having lived through that, it was a bit of a almost like, why didn't I recognize this, that fibers going into the environment were going to be a problem? So when it first started to become a thing, it was like, wow, I don't think a lot of people had considered it, and particularly for synthetic microfibers. I think those of us that have worked in industry, we see a lot of lint and a lot of dust formed from natural fibers, but from synthetics, you don't see much in a factory. So to see that these were then getting into the environment, it was a bit of a wow. That's sort of it's not something that we knew about, and we've been kicking a can down a road and delaying action. So you could argue with things like effluent treatment sludge. It's something we've been aware of, and it's been not a top priority, and we've deferred it. But with microfibers in the environment, it was like, wow, a bit of a wake up.
Yeah, and I mean, we've all been into factories where we see the plastic sheeting around knitting machines, preventing the fibre fly and things like that. So we've seen it actually on the ground in the facilities. So yeah, yeah, good to see that we can do something about it now. So for me, you know, if we think about the kind of curiosity, kind of what started, I mean, I'm a material person, and it just seemed obvious that, you know, when you look at a material, I kind of like to think of it like cake. It's always great to talk about cake. You know, you're putting ingredients in, you've got a methodology of how you're doing it. That can all be tweaked and changed. And I think that's what first excited me about the topic, that there was opportunities, even though at the time we were seeing this as a bit of a light bulb moment. Oh, you know, we haven't thought about this. Fibers are being shed from materials, but turning it the other way round, it felt like there was huge opportunities that we can actually influence change at many different levels. And in a minute, we can kind of get a little bit deeper into kind of what those opportunities are. But I still think today, even when we start to put fibre fragmentation and climate together, although it might seem difficult, that there are opportunities at various different levels of where that change can actually happen. And I think when we go back to what Lucy was saying at the beginning, you know, 1.8 1.8% of annual global greenhouse gas emissions comes from the textile industry. That's massive, you know, and we need to take that as an opportunity of the change that we can actually create. So if we kind of start to look at climate with regards to this topic and how it kind of comes together, we've heard from Elliot on the evidence, and I think it's really good to have that framed up in the early part of today's conversation. The kind of key three areas that he spoke about is the effect of microplastics and microfibers on our ocean, disrupting that carbon storage potential. He spoke about sea ice and the effect on plankton and organisms in the sea. Then also, perhaps, which is little more surprising or less obvious to people, is the effect on soil and how the soil biome is affected, and ultimately there changes gas emissions. greenhouse gas emissions, and then microfibers in the air and how that alters the cloud formation and atmospheric cooling. So 3 key areas of how it's cutting across fibre fragmentation and climate. So as we kind of think about those, it would be good to kind of get into your world a little bit more, and how things could potentially be changed up, or get an understanding of what's actually happening in the kind of the factory level, because I think we've got opportunities both during manufacture, and then we've also got opportunities with regards to fabric R&D. So could we start maybe, Phil, and think about what is actually happening at the factory level, and some of the actions that are being taken already to address what you see as kind of climate-based actions, which also could potentially affect fibre fragmentation as well?
Yeah, obviously the 1.8% or 2% of GHGs as a result of textile manufacture is obviously huge. If we stop the creation and release of microfibers, it wouldn't make a massive dent on that. Let's be honest about it. So in terms of dealing with the majority of that, then it's about being more energy efficient. It's about having efficient boilers, efficient generators. It's about having new machinery that uses less water. There's all sorts of things that you can do. You can have heat recovery. You can start using renewable energy, and those are things that will make the biggest dents on that amount. But in terms of the formation and mitigation of microfibers, there's a lot that we can do, and I don't pretend at all to be a marine biologist. So listening to what Elliot's got to say, you say, well, is there any downside in doing your utmost to stop the formation and release of microfibers? And to me, no, not really. It's something we should be doing intuitively, really, that we should be taking steps to reduce that. So what you can do within a facility, that there are certain machines where you've got a fabric that goes round and round and round, and it gets abraded. So in a typical jet dyeing machine, or in a garment laundry machine, or a garment dyeing machine, and there are things you can do to reduce that level of abrasion, either by changing the machine parameters, speeds, temperatures, etc. You can put lubricants in there, or you can look at machines that are less aggressive. You can put filters on machines to locally filter out lint. Now you have that on things like jet dyeing machines, and they get full of cotton fibers, typically on a cotton dyeing process, or a viscose dyeing process. But you could augment that with finer filters. There's things that you could possibly do in the future. With physical finishing, sueding machines, bushing machines, etc., there are extraction systems on there, but could they be improved? One of the issues that we see is that fabrics and garments that leave a facility are essentially covered in dust. The loose dust is there. Can we insist on people putting vacuum slots on fabric finishing machines to take off that loose amount of material? Can we in certain instances ask that people wash products pre-sale to remove that loose material? So there's things that can be done about the formation of microfibers. There's things that can be done about the mitigation in terms of a material. But one of the key areas that we're looking at is the release in effluent. And I know on the list of people on the call today, Jimmy Summers is on the call. Jimmy sits on the ZDHC Wastewater Council, which I chair, and we've worked together with TMC to really make a parameter called total suspended solids a key priority parameter in wastewater control. Historically, people have thought of this as a bit of solids, a bit of silt in a river, nothing really to worry about. But by ramping that up and making a clear link to microfibers, that's now on the agenda for facilities, for brands, for legislators, and we'd expect that to probably ratchet up and become more stringent over the years. So this is the other thing with effluent treatment. People have got to settle them out or filter them out, so that we don't get those releases into the environment. And the technology's there. It's really quite simple to do. And I think we need to share our learnings with municipal effluent treatment plants as well, so that then deals with the consumer laundry issue. I know people are pushing for filters on washing machines, but that's going to take years. But if we can get municipal wastewater treatment plants to operate in the same way as hopefully textile wastewater treatment plants work in future, that will be great. If we because we can virtually eliminate releases from the industry in water. That is really within our grasp. And then coming on to soil, what we do in a lot of effluent treatment plants is we settle the microfibers into the solids, into the sludge. And unfortunately, at the moment, a lot of that then gets spread on land. And that's crazy. We remove it in with one hand and put it back into the environment with the other. So this is something that the ZDHC Wastewater Council are looking at, is can we put a restriction on land spreading in the next few years, so that we don't have that silly situation where we remove a problem in one area and then create it again. So there are controls in there, and it doesn't need rocket science. It just needs a little bit of thoroughness and diligence.
Yeah, and this is great because I mean, what you brought up today, and we're talking about climate, is actually crosses right over the previous webinars that we had around pollution and biodiversity as well. And Scott Eccles from ZDHC represented this same work in those two webinars. So although we have segmented them as pollution, biodiversity and climate, there's a lot of synergies that go right across. So I think if people are reaching out to their supply base and they're asking for things to happen, where you're making progress in one area, you're also going to be supporting the other areas as well. So are there some easy wins then that people can have as they talk to their suppliers? You talked about the work with ZDHC and some of the other smaller actions that aren't kind of rocket science, as you put it, with regards to what could happen at a facilities level. But you feel that this is very achievable for people to go out to their supply base and ask basic questions and start to get the suppliers on board with this.
Yeah, I mean, the first thing is to ensure facilities are meeting the total suspended solids limits. That's a relatively easy one. If anybody isn't, then put pressure on them for them to meet that. Within the ZDHC wastewater guidelines, there are tiered limits. So there is a foundation limit, and then there's a progressive and aspirational. And if you can push your suppliers to get to the progressive and aspirational limits, that can reduce the emissions in effluent, by, I forget the exact figures, but like 85% and 95%, huge reductions. So that's a relatively easy win. An easy win technically is to use better quality yarns, particularly cotton. Look at yarn singeing. And not biopolishing. The biggest cause of problematic microfibers is biopolishing of cotton product at the moment. And that it's avoidable, and also linked in with a wider sustainability debate. If you biopolish, you reduce the strength and durability of the underlying fabric. So there are things that can be done, but it isn't rocket science.
Yeah, great. You spoke about cotton there, and I want to, just for the audience today, is we're seeing this coming through in both synthetics and natural fibres. So we're not trying to advocate for one over the other. Both of them have their own issues associated to them. So again, it goes back to truly understanding the material, making sure that that material is fit for purpose and you're putting the right material in the right products, and understand the consequences of using either of them.
Yeah.
Okay.
But
so
if I'd got a concern priority in terms of fibres, synthetics, that they're not going to biodegrade readily at all anywhere. Dyed natural fibres, depending on what they dyed with and what they finish with, that can have a significant impact on biodegradability. I mean, I mentioned my years ago I worked on lyocell, Tencel. If you dye that with the most common black reactive dye in the world, it cross-links it. You can't eat it away with an enzyme. So there are impacts of dyes and chemicals on natural fibres. And then at the bottom of my worry list is undyed natural fibres. But of course, if these find themselves into the ocean, despite some what I would say is dubious methodology that claims to prove these biodegrade. Not a lot biodegrades in the ocean. It's 4 degrees. It's salty. There's hardly any bugs there. Things hang around for centuries. But yeah, that's my priority listing of different fibres.
Okay, brilliant. Thanks, Phil. So I'm going to move us a little bit from the kind of production level of textiles to kind of the R&D level, and where designers and product development teams can actually influence change. Some of the things that I would imagine are starting to go onto people's climate strategies are things like recycled polyester. We hear a lot of conversation about people increasing their usage in this area, and this is an area that TMC has looked at. And for anybody that wants to, there's resources as a report through TMC where they can get information about that. And also things like solution dye, not, again, you talk about rocket science. It's not rocket science. It's been in the industry for a long time. I know people are adopting it because of less water, less energy use, etc. And before the webinar today, Elliot was looking in the data portal for us to see how much data we have around solution dye, because I know in the early days, TMC did some pilot research, some very elementary research in this area to try and understand if there was a difference in dye methods with regards to fibre fragmentation. We did find slightly preferential results for solution dye as opposed to jet dye, but I will caveat that with saying where we looked at 154 jet dyed samples, we only had 4 solution dyed samples. So I think there's a huge opportunity for the community, for the topic community, to start to look at what they're looking at with regards to materials and their materials strategy for climate, and ask the question, well, actually, if we were to test this, would we also see preferential results for fibre fragmentation? And solution dye is just one example I wanted to bring up today. For me, it's always been something that, if there's less processing, if there's less water, less agitation, temperature, chemicals, etc., it could potentially have an effect on how that fibre is going to fragment later on during wash and wear, etc. So I think that is perhaps a little bit of a call to action to people on the call today. As you're working with your design teams and looking at your material strategies, start to look at the materials that you're wanting to put forwards and see whether there's opportunities to also look at them from a preferential fibre fragmentation point of view.
Yeah, I mean, there's an argument to say that we shouldn't conventionally dye any polyester. Dope dye is brilliant from an environmental point of view because you combine the yarn manufacture with the dyeing stage. And then I don't know as you say, this 4 samples versus 150. So more research will be needed, but
yeah, definitely.
It's not doesn't surprise me that the resulting products don't shed as much, because typically a polyester fabric is going to be in a dyeing machine for a few hours, or a yarn's going to be in a machine for a few hours, subject to chemicals, high temperature, abrasion in certain instances. Whereas a dope dye is like to be made into a knitted or woven fabric and then given a bit of a rinse, before it comes to market. So that to me, you'll get potentially a double whammy, but from a not having to diet perspective it makes sense.
And I think these are all the things that, when I first started this work, really excited me, because I wanted to make sure that the change that we were creating was as close to the root cause as possible, so we could actually influence impact much earlier on in the production cycle. And I know earlier on today, Phil, when you and I were talking, we were getting really deep. We were talking about the polymer level, especially with solution dye. If we're affecting change at that polymer level, how can that influence change? And I know some of the early conversations I had weren't necessarily with the fabric suppliers, but the polymer suppliers, and how we could actually modify the polymer even to influence change later down the production stage. So
yeah, I think if you could make such modifications to give a non-fragmenting or a low fragmenting fibre, then that could be very, very interesting. I think that, but new materials are interesting, but we've still got an industry that's dominated by polyester and cotton and a few others. So I wouldn't pin the hopes on fibre fragmentation, microfiber loss on new materials, because I think it will take forever for something to then become a dominant fibre. I think we've got to concentrate on mitigating the problems that we've got with the fleet of major fibres that we're currently dealing with.
Yeah. I see that Anna's jumped back on, so I know my time is running out, but I just want to wrap up with one final point, Phil, from you, and I'll add it as well. What gives you hope? We've asked all our other speakers through this webinar series, one key point that gives you hope.
Well, I've got three, but I'll be brief. One is that we've already got microfibers on the map in terms of ZDHC water guidelines, so that most brands will be making sure that people meet those minimum requirements, and those hopefully will ratchet up to meet the higher standards. So we've already got it on the map from a manufacturing point of view. Hope, just from a common sense scientific point of view, these things have got size, they've got shape, and they can be settled and they can be removed. So we're not looking at an impossible task here in terms of massively reducing the amounts that are released. And then the other thing is, when you're old like I am and you've seen things change from being very difficult to being possible, I would give the example of chemical management. So 25 years ago, chemical management was something that not many brands were really interested in. And if you wanted to get your supply base to do things properly, it was difficult and there'd be pushback. Then you start getting a few more brands involved, then you get multi-stakeholder organisations like the Affirm Group and like ZDHC, and it becomes the norm. So at the moment, microfibers are sort of 4 or 5 years from the start, so it's relatively new and there's great engagement. So I see this as something that's not insolvable problem. That said, the stuff that's out there already, the toothpaste out of the tube there, there's problematic fibres out there, and I don't see how we're going to remediate that. It's really a case of stopping releases in the future.
Super. And for me, just to wrap it up, I see opportunities both in production and fabric R&D. With the challenges that we have, we're not trying to just recreate a better version of what we have already, but use that as an opportunity to really innovate your materials, use it to create the next thing. So I think it's exciting times ahead. And thank you very much for your time today, Phil. And great to have a chat with you today. So handing back to Anna.
Thank you both so much. I feel like this is just the start of such an exciting conversation in terms of, when we're considering the actions that we need to take in terms of climate and emissions reduction, asking the question, okay, what's the effect that this change might have on fibre fragmentation? And so, I think this is really just the beginning, and we want to carry on these conversations. So on the screen here, I share a QR code for you to apply to join the TMC Open Hours, which will be beginning in March next year. This is really to discuss focus questions on the implementation of fibre fragmentation as a topic across the broader sustainability agenda. So it may be like today, we'll be talking about climate, or we'll be talking about fibre fragmentation and biodiversity loss, and so on. So they're really going to be relatively small groups, but we're going to hold 3 sessions to begin with, and of course, listen to your feedback there and carry those on as we continue this journey of embedding fibre fragmentation action across the sustainability agenda. And as we've got 1 minute left, I also want to share with you that our recordings of previous webinars are all up on the resources page of our website, so you can catch up on the other conversations that we have had throughout this series, because really a wealth of knowledge and information has come from starting this conversation, and this really is just the beginning. So thank you for joining us, and please stay tuned for more, and we will be continuing this conversation of fibre fragmentation and the triple planetary to support you on this journey. Thank you all for attending.